We are beginning Unit 6. We're starting with area and Riemann sums. Have you found area of figures before? Yes. Was any of it crazy difficult? Not really, right? So area, you know how to do. Riemann, these Riemann sums, they are named after a dude named Riemann. But anytime you see the word Riemann, it refers to rectangle. So, are you capable of finding the area of a rectangle? I certainly hope so. So then we should be able to get through this with no problem. So here's what we have. We have this little graph, very simple graph too, right? As particle P moves along a straight path with a constant velocity of 2 feet per second, the graph of v sub p of t is shown below. Okay, so your x-axis is t, your y-axis is v of t. Really v sub p of t, but okay, so this is not a time and distance graph like we're used to. It is a time and velocity graph. So we're going to look for the total distance of the particle traveled. So from physics, or even before physics, really just a basic science class, because I know you talk a lot about that. If you were looking for distance, what is your basic distance formula? What times what? Anybody? Rate times time, does that sound familiar? Times time. Oh my gosh. Distance is equal to rate times time. That's even probably junior high science at some point, or some basic physics, that should be like a time. Rate times time, that's how you find the distance. So instead of having, so if I had the time and the distance, your rate is distance divided by time, right? Like miles per hour. If I divided that over, that gives you your rate. So think about that. If your rate is miles per hour, you multiply both sides by hours, then you get the rate times time, that gives you your distance. That's how we find it. That's when you do like, I went 60 miles an hour for 2 hours. You rate times time and you get 120 miles, right? That's the basics of that. All right, so I'm looking for the total distance of the particle that has traveled, or the total distance the particle has traveled. So when I look at this and I want my total distance, okay, I'm going to take my velocity, which is v sub p of t, and this right here is my rate, my velocity, right, times the time, and then the time in this case is t, right? So distance is equal to rate times time, so that's my velocity times my time. Okay, so what is the velocity of this particle? 2 feet per second, because it's constant, right? So my velocity, because this is my y, this is my 2 feet per second, right? So I'm going to even write it in there as 2 feet per second. Okay? Times, what would my time be? 2 seconds, right? Because this is 2 seconds. This right here, my velocity is 2. So we basically did 2 times 2. And what we end up getting is the area under the curve that I know is not really curvy. So I know that 2 times 2 is 4. When we do that, the seconds cancel out, and I get 4 feet. And if you think about it, if you're traveling 2 feet per second for 2 seconds, right, that's going to be 4 feet. Okay? And I know you can figure those things out when you think about it, but we kind of need to think more about how it's actually working and writing some stuff down. Make sense? So that's the basics. That's an area under the curve. We just found a Riemann sum because there was just one. Sum means we're going to add them up, but there was only one there. All right, so it says probably what I just said. Notice that the total distance the particle traveled correlates with the area between v sub p of t and the x-axis. This idea of connecting total or net change, or accumulation is a word that we're going to see a lot, to the area bounded by a rate of change function is one of the key concepts that intrigued the early calculus pioneers. All right, so we're going to consider this data below that models the velocity of a car, so v of t, in feet per second. And if those things weren't actually written out here, we'd want to label that so we can make sure we don't mess up on our units and whatnot. With respect to time, that has elapsed in seconds. The velocity of the car is always increasing over the domain from 0 to 12. So that's important because if they give me this and I don't have a graph, I can plot these points, but I wouldn't know if the curve looked like that or if maybe the curve looked like that. Because it does, just because this is always increasing doesn't mean that everything else is always increasing. Does that make sense to you? Like it could look like that somehow. All right. So it says the graph to the right shows the data in the table. Notice that the data seem to make clean geometric shape like the graph above. Approximate the total distance the car has traveled over the interval from 0 to 12. So see if you can approximate that by finding the area under the curve. Now it's a curve, but again, we'll try and make a clean geometric shape out of it. See what you can do. Give you a second to think about that and see what you can figure out. What geometric shape do you see? Do you see a, well, I called this a rectangle. Yeah, but technically this is also a square, right? Do you see a trapezoid? Could you make that into a trapezoid or more than one even? Or you can split it up. There you go. You've got different ways to do things. I'm okay with that. It is a curve, so we're still approximating or estimating. Let's see what you can estimate here. That works. There's different ways to do things. You don't have to. Don't shame somebody. And then do some math too. Don't just draw pictures. And done. Okay, looks good. So we're looking, what's the argument back here? No, what is the discussion? It's okay, it's okay.
Okay.
I want you to.
Into this part into a triangle, so I'm just
Okay.
approximate
Right.
for this.
Okay.
But don't we have to do
Yes,
this?
because, okay, yes, because what we are looking for, and I'm going to erase this because my curve is not going to look good. You are looking for the area, oh my gosh. You are looking for the area, like this is technically a curve, right, even though it looks kind of straight. And from here, you're looking for all of this. The area under the curve that's bounded by the x-axis from 0 to 12. Okay, so yes, that is what you're looking for. And I'm going to erase that so I can. I'm going to talk about some different things that y'all done. I heard the word trapezoid, but do you have to do a trapezoid? No, you don't have to. Let's see. And I would encourage you, use a straight edge like the ID that's supposed to be around your neck to actually connect that so you can see that it's not as straight as you think it is, right? And we are approximating. This is an important word, okay? And I heard the word trapezoid, but this is what I've seen a lot of, drawing this and making this triangle. Is that acceptable? Absolutely. So we have this triangle here. Oops. It's hard for me to hit my, what I'm aiming for here. Okay, so then we also have this rectangle down here that we have to deal with. That's a little off, but we're going to, maybe I can try and make it better. Let's see. There we go. And, oh my gosh. Okay. So if you don't, how many of you remember, you don't have to tell me what it is, but you remember the area formula for a trapezoid? Okay. Do you know what it is for a rectangle? Do you know what it is for a triangle? Okay, so splitting it up like that, totally fine, right? So what Daniel got shamed for doing was drawing this, actually I'll use a different color. Unfairly got shamed for doing, let's put it that way, was drawing this oh, I did it too high, hang on, sorry, messing it up. I'm sure he probably did it way better than what I'm doing here. He drew this in and basically made two rectangles, right? A bottom rectangle and a top rectangle. And he said, well, it's a diagonal that goes through the rectangle, so it's half the rectangle. Could you find it that way? Yeah, because the rectangle is base times height, and you multiply by 1/2. That's the formula anyway, 1/2 base times height. Whatever makes the most sense to you in situations like that is fine, right? You make it work for you. So let's look at, so did you actually come up with a number? Some of you still have numbers on your paper. Let's see, this is 12, right? So that means that this is 6, 3, 9. This is 30. And this is 65. Okay. Yeah, you can just add them up. Because remember, these are called Riemann sums. Now, the triangle is not a rectangle, but it's still a sum that helps us with this, and I'll clarify all of that. But notice when you do base times height, you're multiplying these two together. So you're multiplying feet per second times seconds, which is going to give you feet, which is going to give you that total distance, right? So my distance is going to be equal to, that's 12 times 30, right? 12 times 30 plus 1/2 times 30, base 30 times 15, all right? Are my numbers right? You agree with that? No, it's not 15. Why do I have 15? It's 35, right? I'm making stuff up. The height right here, that's 35. Do not ask me where I got 15 from. I have absolutely no idea. Are those the right numbers? No? Oh, I used 30. Good Lord. I don't even know what, okay, forget that. Yesterday, sorry. I haven't taught in a few weeks and my brain is not working. The base length is 12. This is what I was trying to get at, right? The base of the triangle, this right here, that is 12. That's what I was trying to write here, and I kept writing 30 and then confusing myself. The height of the triangle, this is also why you should label your triangle, right? From 30 to 65, this is 35. Now, do we agree with me? Okay, good. I knew what I was writing down was wrong, but I couldn't figure out what I was doing wrong. And then this is my base times my height, 1/2 base times the height of the triangle. Everybody good with all that? Yes? Ask me if you're not. Okay. So what is 12 times 30? 360. Okay. So instead of multiplying 12 times 35, I'd rather take half of 12 and get 6. What's 6 times 35? 180 plus 2. Yeah, it's plus 210. Okay. Okay. And then when I get that, my total distance is equal to 570 what? Feet. Okay. Now keep in mind, this is an approximate distance, right? Do you think what we have is an overestimate or an underestimate? It's an overestimate, right? Because when I drew this in, since this is actually a curve, I can see that I found this area in here that I don't really want, right? But depending on what we need it for, the approximation might be okay. Could we make the approximation better? How could we make it better? Okay, what if, any ideas? No? how could I basically redraw something very similar to what I have to make there not so much of that space in there that I don't want? Any ideas? Smaller rectangles? Or smaller trapezoids, basically. But yeah, what if I did, let's see, let me make it a different color. Instead of connecting this to this, what if I made this little triangle here, and then this one here, and then connected these two, and then connected those two, like that? Would that be much closer? It would be much closer if I made smaller little intervals, right? Let me give you the actual distance, just as a little FYI, and then we're going to talk about what to do. So the actual distance is 549.257 feet when you actually use the calculus to get that, which we are getting to. We're just doing very basic stuff today. But that's a semi-decent estimate, again, depending on what we want it for. But as long as we know if it's an overestimate, if we're calculating, to see if we have enough gas or whatever, then we should be fine if we have an overestimate, right? Okay, we good at this point? All right, so then flip it over. Now, it says in calculus, we typically choose to approximate the area bounded by the curve by using rectangles, that's your Riemann sums, or trapezoids. So we are going to need to know the formula for a trapezoid, but that's okay. I'll get you there just fine. When using rectangles, Riemann sums, we ask two questions. How many rectangles should I use? But here's the good news. The number of rectangles you should use is whatever the question says. It'll tell you, okay? How will I determine the height of the rectangle? Will I use left endpoint, right endpoint, or midpoint rectangles? So it's important that you know the differences here. It's also important that you understand how these will be graded so that you can get as many points as possible by showing your work, because there's usually worth multiple points and it's the same points every single time. Okay, so we're going to use the card data from earlier to estimate the total distance using the different ones. We have left Riemann sums, and I just realized my, dang it. Okay, we're going to redraw this sum because, bless you, we're going to redraw this a couple of times. I wish this was on more than one graph, and it was last year, and apparently these are a little bit different. Same question, but all right, it's fine. We're going to start with left Riemann sum, and it says 4 equal subdivisions on the left endpoint. So basically it's telling me to use 4 left hand, this says left Riemann sums or left endpoint, left hand rectangles can also be how it's said. And it tells me 4 equal subdivisions. So I'm going from 0 to 12, and I have to split this into 4 equal parts, which is what we had already, right? So this is 3, 6, 9, and 12. So I have 4 equal subdivisions, not just 4, they have to be the same, okay? Now, left endpoint, you have these intervals, okay? My whole interval, I'm going from 0 to 12. But my first interval is from 0 to 3, then I go from 3 to 6, then I go from 6 to 9, then I go from 9 to 12. That makes sense? Okay. So when I want to write this down, my entire distance is approximately, right? And we're going to put brackets on this because we want to be able to put our units at the end. We're going to split this into 4 rectangles. When it's the left hand, and notice it says left endpoint, if my interval goes from 0 to 3, then I start on the left-hand side of the interval from wherever my curve is. I just drop a line down, right? And then I'm going only to 3, so I'm not making like one giant rectangle like we did before. I'm going to make a horizontal line there and then drop back down. Okay. Then when I go from 3 to 6, I'm going to drop down from here and drop down from here on the left-hand side, and then I draw my rectangle. One of the reasons this can get confusing is because we're drawing to the right, right? It's not how you're drawing it, it's where you start. You start on the left-hand side, it's a left-hand rectangle. Then when I go from 6 to 9, since I'm going from 6 to 9 here, I start at 6, drop that down, make my rectangle. Then I start at 9 and make that rectangle. Pretend like it's a straight line. Now, when we find this left-hand Riemann sum, do you think this is going to be an underestimate or an overestimate? Underestimate, right? Kind of seems obvious right now, right? When we're looking at it, we're actually doing it this way. We'll figure out how to know if we can't actually see it as well. We also want to label our graph. So this is velocity, and this is time. Okay? And this is feet per second. And this is seconds. Okay? Label that stuff so you don't forget to use it and you don't do anything wrong here. Okay. And then I'm going to rewrite this so that I can write bigger. I'm going to leave it like this. Is approximately, but then I'm going to write it under here so I can start farther to the left. I have 4 areas I have to find. What's the area formula for a rectangle? Base times height. Okay, so when I start with my first interval going from 0 to 3, what is the length of the base? 3, okay? So I'm going to have 3 times, what is the height? 30. This is 30. So 3 times 30, right? Plus, then I go to my second interval. When I go from 3 to 6, what is the length of the base? 3. What is the height? 37, because look, when I look at my height right here, this is my x value, that is my y value right there, right? Because you can't really pull it off the graph. So 3 times 37. Plus, then when I go to this interval from 6 to 9, what's the length of the base? 3. And then the height is what? 45. Good. 3 times 45. That's a weird looking plus sign. And then I have my last one here. What's the length of the base? 3 times what is the height? 54. Okay, so you double check yourself. I have 1, 2, 3, 4 rectangles. Does it make sense that every single one of these has a 3 in it? Yes, because they're equal sized rectangles, right? Guess what one of the #1 mistakes is that people do? Instead of putting 3 every time, they put 3, then 6, then 9, then 12. And that doesn't make sense, does it? So make sure that you're thinking about that's the size of the interval. Right, so then we close this up, and my units were feet per second times seconds. So when I actually found those areas, what are the units on this? Feet. Okay. Now notice up here, we have 1, 2, 3, 4, 5 values. We only used 4 of them. Like the 65, we didn't use at all, and that's totally fine. Okay, we all good with that? Easy enough? Okay, so the biggest challenge with these is, or the things that happen the most that get you wrong answers, are not using the right numbers, obviously, and not understanding the difference between the left and the right-hand side. Okay. And I was looking to see where I want to draw the next one, because I don't want to draw all this on one picture. This was a bad thing. I did not catch that. Where's some more room? I write so big. Let's see. I'm going to erase this, and we're going to draw another little picture right here. Because a lot of the times the pictures aren't going to be drawn for you. You have to draw them. So wherever you can do it, even if it's maybe on the front. What does this look like? Fold it up. Oh, you know what? You could probably fold yours up if you wanted to, and maybe write it right there. It's up to you, or whatever works. As long as you can figure out what it goes with, you would want to have it labeled. could probably, well, it doesn't have to be huge, but I'm going to put mine right here. Okay, so we're just going to do another, we're going to make a little graph, and it's just a sketch, right? Just a sketch, it doesn't have to be beautiful. I'm going to put this curve in there, whoop, something like that. And we're going to go from 0 to 12. So 6, 3, 9. 3, 6, 9. That works. Something to that effect. Okay. All right, so this, again, we're going to do 4. That's why I did the 3, 6, 9, 12, because we're doing 4 subdivisions again. So I have that lined out. Now we're going to do right Riemann sums. So my first interval goes from 0 to 3. I start on the right-hand side and drop down from the curve, and then draw to the left. There we go. Okay, so that's my first one. Then I go to 6, and that's the right-hand side of this second interval. Drop down, draw to the left. Then I go to 9, the right-hand side of the rectangle, drop down, draw to the left. And then do the same thing for 12. Except kind of don't make it to 12, but good enough. Okay. Now, is this an overestimate or an underestimate? Over. Do you think right-hand Riemann sums will always be overestimates? What would happen? This is an increasing function. If it was decreasing, it would be the opposite, right? So it just depends on the function. And again, it could be increasing and decreasing throughout, so it might not be there's not a general way to state that. Okay, so now when we look at this, we're going to find the total distance, and it's going to be approximately, so we have to say it's approximate. That's one thing that they look for. And then we are going to find the areas. So this first rectangle, what's the length of the base? 3. What is the height? Because we do it from the right, it's 37. Because I'm at 3, I want 37. So it's 3 times 37. Scroll a little bit. Then I'm going to go to my second interval. What's the length of the base? 3. So plus 3 times the height of the rectangle is 45. Plus, what's the length of the base? 3 times the height, which is 54. Plus, what's the length of the base? 3 times what's the height? 65. Okay. And what are my units? Feet. Okay, so what have I not done on either one of those? Actually come up with an answer, right? I mean, we could if we wanted to, but we don't have to, so don't. Are you capable of it? Sure. Are you capable of making a lot of mistakes in it? Sure. I couldn't even write down the right numbers on the last one. So what they're looking for, one of the things they look for is like if you have, let's say we have 4 rectangles, you have to have, so there's 8 numbers, you have to have 7 of the 8 numbers right. So because you're writing so many things down, they kind of give you a pass if you accidentally copy a wrong number down, but it can only be 1, right? You have to have the units correct. You have to show that you're actually adding them up and show that maybe you had a picture for it, right? That sort of thing. But that's it. Unless it's a calculator question, they're not going to ask you for the actual sum of it. Just how do you find it and what does it look like? Okay, we good with that? All right. So then we have midpoint Riemann sums. We can draw that one right here. So just again, we're just going to kind of sketch in this curve, something like that. Now, and it says 2 equal subdivisions. I'm going from 0 to 12. Okay, so that means 6 is halfway, right? So what's the base of each one of my rectangles going to be? What's the number? 6, okay? But then the height is based on the midpoint, like it says right here. So halfway between 0 and 6 is 3. Halfway between 6 and 12 is 9, right? So instead of starting from the left or the right, you start from the middle. So at 3, I'm not going to drop a line down that time, but at 3 on the graph, that's my height. I start there, I draw it to the left end, and I draw it to the right end, like that. Then 9, I go up here. That right there, whatever the y value is when x is 9, that's my height. And then I draw the rectangle to the left and to the right. That's why we can only do 2, because we only have enough data for 2 of them. Okay, so our distance then is approximately, okay, what is the length of the base for the first rectangle? 6 times, what is the height? 37, yes, because that's where, when x is 3, what is y? That's what we're looking for. 37 plus, what's the length of the base? 6 times what? 54. And then I put feet on there. Do you understand when we're writing this why we have to have the brackets? If I didn't, then I'd just be putting the units on that last term, right? So that those brackets are important there. All right, what questions you got? Do you understand the basic concept there? Okay. And let's look at this one then. So water is flowing into a tank. I didn't print this out, so we're going to wing this here then. All right, water is flowing into a tank over a 12-hour period. The rate at which the water is flowing into the tank at various times is measured, and the results are given in the table below. Well, where R of T is measured in gallons per hour, and T is measured in hours. The tank contains 150 gallons of water when T equals 0. Okay, so it says use left Riemann sum with 3 subintervals to estimate the area under R of T from 0 to 12. So I would suggest drawing a picture, especially at the beginning of all of this. It doesn't have to be beautiful. Nobody's really judging your picture, but it's going to help you make sure that you're getting the stuff correct. Now, this is, so let's just draw a little picture over here. And I'm going from 0 to 12 again. It seems to be popular there. And I'm going from 8 to 9.2. Does it say in here? Let's see, it's flowing into a tank over a 12-hour period at various times as measured. So even though it's flowing in, it doesn't say that it's flowing in like at a constant rate or an increasing rate. These numbers are increasing, but remember that your graph could actually look kind of wonky like this, like we don't really know. Okay, it's just, it is what it is. And so we're going to go from 0 to 12. And it did say, it says 3 subintervals. So that means that I'm going to have 3 rectangles. So what are these numbers? What is 12 divided by 3? 4. 4, and then 8, and then 12, right? That's why 12 gets used so much, because it's divisible by 3, it's divisible by 4, it's divisible by 2. Okay, yeah. All right, I know those crazy hard questions, right? It's all good. Okay, so left Riemann sums. So I have my 3 subintervals. If it is a left Riemann sum, which side of the interval do I start on? The left, just like it says. That's where we start, not where we end. So I start on the left-hand side of this first interval from 0 to 4, and I drop down my line. Then I have my rectangle. Then I have from 4 to 8, I start on the left-hand side, drop that down, draw my rectangle. Then I start on the left-hand side, drop that down, draw my rectangle. I have no idea how accurate my picture is because I don't really know exactly what's going on and I don't necessarily really care, but the picture could help you. Now, when you're looking at something and you're not looking at the picture here, you're going from 0 to 5, and then from 5 to 8, and then from 8 to 12. These can almost kind of serve as your rectangles as well, because on the left-hand side, your x value is 0, your y value is 8. So you use the y value on the left-hand side of that rectangle, right? So when we're looking at this, and I say my distance, so I'm going to find this first. Distance is approximately, okay, so what is the base length of this rectangle? 4. What is the height? We didn't hide this. The height is this right here. Would you agree with that? Yes? What is this x value? 0. Well, when the x value is 0, what is the y value? 8. Okay, that makes sense? Yeah. All right. Plus, that's okay. What is the base length of the second rectangle? 4. What is the height? Oh, sheets and letters. No wonder y'all weren't answering my question. I'm going to change the 5 to a 4. Here's what happened. Sorry. It does. What does this not say right here? Equal. 3 subintervals. I have to use the data they gave me. No wonder y'all couldn't, weren't saying 4. I was like, oh. And Jesus Christ. Okay. I'm sorry. This is so embarrassing. Okay. So this should be a 5. That should be a 5. So if you were right, why didn't you say something? Haven't y'all learned by now? Sometimes my brain is just, I only half read the question. Here's another way you make mistakes, is half reading the question and not paying attention to what you're doing. Good Lord in heaven. Okay, is this 8 still correct? Yes. Is my 4 still correct? No. This should be what? 5. Okay, so that's actually 5. And then is this 4 correct? No. What is this? 3. See? You're paying attention more now, right, too, aren't you? Maybe this is helpful when I'm an idiot. I don't know. Okay, then what is the height? 8.8. Now, if you do what some type of thing like I just did, you see how I caught myself? Like, holy Jesus, I can't do that. I must have done something wrong. And that's when I went back and I could figure out what I did wrong that time. All right, so it's really 5 times 8, 3 times 8.8, which if you do this kind of thing, I mean, here's a teachable moment. This kind of thing on the AP exam, this is okay too. Don't worry about trying to erase it and spending time doing that and making a hole in your paper. Just mark it out and replace it, and that kind of stuff is acceptable because you're not going to, most likely, at least I wouldn't be perfect all the time on all that. Okay, so then plus, is this right? Yes, 8 to 12. Okay, what is this one then? 4 times, what is the height? 9.3. Okay. And then what are your units? Gallons. Okay. And sometimes the units can be weird, right? Sometimes it's like weird things that we'll look at, but we're just multiplying them together to figure that out. Okay. We good? I will try to take some smart pills during lunch tomorrow.